And now I'd like to introduce our penultimate speaker for today. Thomas Intveld is CEO and co-founder at Tasman, a boutique data analytics agency that delivers data infrastructure, data insight, and data teams for fast-growing clients. The talk is called Data Modeling for Startups. And here he is, Thomas Van Elst.
Thank you. Thank you for the warm reception. Well, let's see if this all works here. Hi, everybody. Good afternoon. Come join us, come join us. Thank you for the invitation to talk here. It's really nice to be back after a couple of years of webinars and all the entailing complications, to be back in front of a live audience. It's my pleasure to be here. I'm very much looking forward to the Q&A in particular, because if you've been to the same webinars that I've been to, the interaction wasn't really that great, right? So let's make sure we save some time for questions later. All right, I'm here to talk about startups. I'm here to talk about analytics for startups. There's going to be some overlap, I think, with particularly Kathleen's talk earlier today. But I'm going to take it for a spin in what you should do when it comes to business intelligence, data analytics, data science, analytics engineering in small, growing companies. Now, I assume that most of you are either in or adjacent to data teams. And so we're going to make sure that this talk is as relevant as possible. First of all, as Wouter, I just put the slide in with the Dutch flag there, just to let you know that the Netherlands is well presented here in the speakers list for today. So I'm very happy to have flown over from Amsterdam. My sort of own little story, just going to take 30 seconds. I grew up in Belgium, studied in Belgium in physics, and then moved to London early 2013, when the sort of data science revolution was just getting started. And I think that gives me a particular perspective for startups, because I've only worked for startups kind of during my career in the last almost 10 years. I then moved to Amsterdam a couple of years ago, but as I will tell you, Tasman and what I do for a living is remote, is global, so it doesn't really matter where you're based, but I've had the fortune of doing data in all three locations, which was excellent. All right, so for whom is this talk? Well, hopefully for all of you, or otherwise we might land into some complicated situations here. But I'm going to talk in particular about sort of three job profiles here. I'm going to talk a bit about data engineering. I'm going to mainly talk about analytics engineering, and just to make sure that the definitions are right here, data engineering for me is about pipelines, it's about making sure that there is data. Analytics engineering is about modeling the data, transforming it, making sure it makes business sense, making sure that we can actually use it. And analysis, data analysts are about turning it into actionable, relevant insight and recommendations, as I have learned from Kathleen's talk. So the talk for today is going to revolve mainly about the center component here, a little bit of data engineering, a little bit of data analysis. I think even if you are not any of these three job profiles, but you are in the machine learning side of things, or if you're in the sort of management, entrepreneur side of things, I think it will still be very useful. Because I'm going to give you sort of three pieces of context here, three sort of themes I'd like you to think about today. One is the sort of realization that analytics for startups, and particularly the analytics tools for startups, has matured incredibly over the last 5 years. I was here speaking at Crunch in Budapest 5 years ago. At that point, even event analytics or event generation as a thing was still very new for startups. I think at this point, you have a luxury of a choice for what sort of event generation tools you want to use, or event collection tools, I should say. Of course, on the sort of data modeling and transformation observability side, there's even more change. So that's very exciting. We're going to talk about that. Yet, at the same time, starting and scaling data teams is still very difficult for a variety of reasons, not all of which are technical. So we'll go through that a little bit, give you some exposure to that. And then even if you figure out most of the pitfalls and the challenges, there's still many different ways of running a data team or setting up the infrastructure. And I'd like to give you some sort of principles to kind of think about when you make those choices, when you set up your data team from scratch. And that is, I think, the difference with doing this in bigger companies versus small companies. If you work for a big company, typically there has already been a setup of a data team at some point, hopefully, so your decision space is a bit smaller. I think what I'm talking about here is if you're running a clean slate project, if you're the first data person in the company, or if you're working as a data professional in a very small, only recently founded team, this talk is for you for sure. I'm also going to already spoil my sort of, how shall I say, takeaways. So we're going to go back to those and tell you exactly what they mean later. But first of all, first takeaway I really want you to remember is when you design data models, Don't do it organically, do it based on the domain model, on a sort of understanding of the business. Takeaway 2 is self-service reporting. We already talked about that today. It can be done, but it can only be done properly if it's well curated with guide rails and guardrails. And takeaway 3 is always prioritize insight that actually changes the business bottom line by making recommendations or by recommending a particular set of concrete actions. So that's the third component here. Very quick word about Tasman. We have been around for 5 years, actually. We just started the company when I spoke here last time. We are an expert-led consultancy agency. We come in with fast-growing companies. We come in to set up the infrastructure, data pipelines, data platforms, data models, visualization toolkits. We set up the first batches of insights, so that's dashboards and reports that are actionable, but also deeper pieces of analysis like customer segmentation, conversion driver models, and so on and so on. And most importantly, we then help our clients to hire their internal data teams, because we think that data is so crucial that you don't want to outsource it to consultants or agencies like us for too long. We do that typically between 3 to 4 months or so, that we actually hand everything over. So we come in, we function as an interim data team, and we bootstrap the internal team, and then we hand everything over and disappear into the sunset. We've been doing that for about 40 clients over the last 5 years, with actually quite a bit of success. So we have now grown to about 20 people. This is from just a few months ago. We are a distributed company working from the UK, Sweden, and the Netherlands, and that means that what we save on office budget, we spend on team away days. So twice a year we get everybody together. This was in May in Rome, when we got everyone together in front of some crumbling Roman ruins, which for whatever reason reminded us of data stacks. So there you go. All right. I'm going to talk about the mistakes that we made rather than tell you exactly what to do. Right, because I can tell you that in those 5 years, and even in my career before Tasman, when I was kind of building my own data teams inside of small product companies, I made a lot of mistakes. I won't speak for my team because, of course, we were very good, but I made a lot of mistakes. And luckily I did, because that means that I can tell you about those, and hopefully you don't make the same mistakes. So my talk is going to be structured around the mistakes that I made, and that I really hope you don't make in the future. So, setting the stage a little bit, just a sort of problem definition that I'm sure you're all aware of, which is that most modern companies, particularly startups, they are kind of expected these days to be really good at analytics. I think that's a kind of expectation from their users, of course, as in you're very angry if the product company you just bought a couch from is still blasting you with advertisements weeks after you've already bought that couch and already kind of have used it. But I think also from an investment point of view, particularly in this landscape of challenging investor money, the sort of expectation that when you invest in a company, it has a really solid, actionable data platform in place is there. It's table stakes, particularly around the Series A mark, we find. Yet many of those companies fall short. So why is that? I think there's sort of 3 main reasons. One is that the complexity of the landscape is very high. That just means there's so much choice. It's very hard to make a sort of decision about data stacks and then kind of have the conviction that it's the best possible stack you can build. It's also just ever-changing, as in we'll go through a few slides later about the sort of analytics tools landscape. Even though it's much more mature than it used to be, there's so many different options. Every day kind of almost has a new SaaS analytics product that hits the market, right? So you got to make your choices right. Secondly, the pressure to grow is mounting. Again, it's the investor landscape in a lot of ways, and it means that the impact of your data analytics platform to achieve scale, which at the end of the day is the goal of most startups, that pressure is mounting. You gotta make sure that your decision making is not just relevant, but is not just actionable, but is also meaningfully driving that growth one way or the other. It also means you need to make sure your data models scale, because you might very well go from a few million events or rows per day to a few 100 million events or rows per day if marketing acquisition is working well, or if you have a lucky day in the App Store. And then the third sort of component is that spending a lot of data, spending a lot of money on data is actually quite easy, but making the insight actionable, again, I will repeat it and repeat it and repeat it, is actually very hard. So let's talk through some examples there. Pitfall number 1, mistake number 1. I made various versions of this deck, and I think at one point I said pitfalls rather than mistakes, so that's why the word pitfall isn't there, but think of them as mistakes. But let's maybe call this one reinventing the wheel. And you'll see what I mean in a second, because this is about data stacks. This is about the tools that you use. This is about the sort of technical decisions that you make that have ramifications all throughout the data stack, whether it's data modeling or data insight or data actions or data reverse ETL kind of feeding it back into your customer-facing tools. There's two realizations. One is that at this point in time, and I mean, it's a continuous evolution, collection, storage, and transformation of data is cheaper than it ever was. That is a fundamental difference from what the situation was like 10 years ago for startups, I should say, right? So startups are fundamentally different from bigger companies because cash flow and spending on something is quite a lot more important for startups typically than it is for big companies. You can kind of iterate your way to efficiency if you're a bigger company in a much easier way than for startups typically. Luckily, the tools are much cheaper than they ever were. Secondly, the analytics landscape has also really unbundled, and it's a bit of a hype word, but it has kind of fell apart into a lot of high quality modular, typically using open core tools. Open core meaning that there's an open source version of it or a managed service version. You can kind of flow between the two rather effortlessly. That's what Wouter this morning talked about as well. I think for Datadog, design considerations were very much around making sure that things were modular and open source based. So with those two considerations in hand, the question then becomes, well, how do you set up a data stack? What are design principles? What should you pay attention to? And then we get to the sort of overview of the landscape slide, which kind of is rather complex. So I'm just showing this to make a point, if you excuse me. This is a slide made by Andreessen Horowitz, so one of the premier sort of technological, what they would call themselves, I guess, tier one investors. And this is an overview of the analytics and data landscape a couple of months ago. There's way too much to go through here, right? But I think you recognize some of the tools, of course, that are in here. You might even use most of them yourself, one way or the other. Luckily, they made a second slide where they just limited it to what tools are available for business intelligence. But even then, the sort of plethora of choice, the different options that you have are quite extensive. So we'll talk through a few of those, but it's very important to realize here that it is modular. You have different tools for ingestion and transport. There's a different tool than your storage tool. It is a different tool from your transformation tool, whether that's metrics layers or just plain data modeling. It's a different tool from the analysis and the output that you actually expect to have from there. And then there's some sort of feedback lines at the bottom. So what I've done is I've taken this and I've simplified it. So let's kind of go through it layer by layer and see where we get to, all right? So this is quite representative for the stack that we built. Again, I'm not here to kind of tell you exactly what to do. I'm here to tell you what you probably should not do, and I'm just going to give you a quick overview of the different layers in this data stack first, all right? Two very important considerations here. First of all is to centralize your data model. The second one is to have a very clear definition of a single source of truth in your data model, and do that from the very start of building out your data team and your data stack. So first, the centralization bit. It means that all of your data sources, all of the sources that produce data, whether that is your front-end application, whether that's your back-end, whether that's a custom API of some obscure financing software you use in the background, or whether that's Google Sheets built by the finance team to kind of contain your financial targets for the month, all of the data, you will really want to load that into the same data warehouse very, very, very early on in the journey. The mistake to make here is to process a lot of this data in pipeline or before it ends up in a data warehouse. And why is that a mistake? Well, the simple truth is that whatever modeling you do at the moment in the growth, the journey of your startup, and don't forget, you're working for a very successful startup, so your startup is growing very fast, and the sort of considerations around data modeling and the requirements of your business are very different today than what they might be a month, 2 months, 3 months down the line. So you're going to make assumptions in that transformation stage, if you do it in the pipeline, that might not hold later down the line. What you want to do is you want to be able to give you as much flexibility as possible inside of the data warehouse to make your data model decisions in a centralized place where you can go back easily go back later and change the way the model functions, change the assumptions and considerations that you have. So that's one thing. Everything in the same data warehouse. Secondly, be careful with the sort of layering of schemas and of sort of abstractions in your data warehouse. So we typically build 3. We build a source layer where we also stage the data. We filter it a little bit. We might transform it. We might sort of check for duplicates. We might do a bit of other filtering and tests on there. Then we built a domain layer, and we'll get to that in a second, what that means. And only then do we build a sort of single source of truth presentation layer that exposes the data to the different tools that might be consuming it. And that's the sort of thing here. Those tools all consume the same data. Do not, whatever you do, mistake number 2 that I made in the past, do not build separate pipelines for separate tools that consume different sources of data, because you're not even going to kind of figure out yourself anymore after a couple of months exactly what data comes from where, and for sure your extended team is not going to do so either. So make sure from the start that all of your tools, whether that's dashboards, whether that's self-serve reporting, whether that's ad hoc pieces of analysis and insight, make sure they consume from the same source. Save yourself the trouble of having to correct for that later down the line. This is what we built, the sort of tooling that we typically use very quickly, just to give you an idea of the technological decisions we make. For ingestion and transport, we really like the sort of open core tools, RudderStack, Snowplow. There's a few others out there, but again, this is my very subjective sort of take on what we currently typically use in a client stack. Airbyte we use as well. Answer the question earlier about Fivetran, why Airbyte and not Fivetran. Airbyte is an open core tool with a very interesting managed service solution. It sits on top of the Singer open source ecosystem, contains connectors to almost everything out there. You do need to, if you run it yourself, it's quite easy to do so. We use schedulers like Prefect to do it, and it just makes for a very easy, very quick up and running solution that we find works particularly well for most of our clients that want the data stack up and running quite quickly. For storage, default solution is Snowflake, but we like BigQuery as well. We like Redshift, but if it's up to us, we typically go for Snowflake these days. I'll go and have a look at Databricks as well, as per the question earlier. I think it's an interesting suggestion that I haven't really explored. But Snowflake, one of the most important things about Snowflake and BigQuery as opposed to Redshift is that, again, if you are not really worried about compute at this point, because your data models are simple, because you're only at the sort of start of your data journey, then Snowflake, it allows you to dissociate your storage from the compute. So typically with a database like Redshift, you provision nodes in your cluster. You need to add a node if you want more computational power, but you also need to add a node if you want to have more storage. And typically that means you have some inefficiencies if you just have much more storage needs than computational needs. Snowflake abstracts all of that away, it just makes it easier. dbt is transformation. It's the standard, I would even say, of data modeling these days. We'll go into what it allows us to do in a second as well, but essentially it gives us a tool to be really rigorous in data modeling, to deploy testing from the start, to have very clear direction in how we build our data models and so on and so on. And then an analysis and output, I think, is quite typical. Metabase is an open source solution for most of our clients with relatively simple reporting needs, and then slowly working our way up to self-serve solutions like Looker and Holistics. And for more deeper analysis, we really like Count, Hex, other notebook tools, or just if all else fails, or even from the start, a Python notebook to kind of make things work. But remember, these tools all consume from the exact same data set. I'm not going to talk about data observability today, but Elementary allows you to run much more sophisticated testing. We really like it. And HighTouch is, together with Census, is the sort of tool that allows us to grab data from the data warehouse and kind of plug it back into the data generation tools, whether that's your CRM system or your Salesforce tool or your marketing tool set or your acquisition platforms. All right, Pitfall 2. We now know where the data model kind of fits into the whole scheme of things, but how do we avoid having data model chaos? How do we avoid having 500 different SQL files that are kind of organically grown over time? And that, I think, was probably from all of these mistakes, the biggest one that I made in the past, is not rewrite your model from scratch early enough. So how you build a data model in a changing business, because remember, you're working for a fast-growing, very successful startup. The data model that you write today for your business stakeholders, or your business stakeholder questions and requirements, they're going to be different from what those questions and requirements are going to be 6 months down the line. And so if you write your data model, as most of you would do, around a particular set of business questions that you get right now, today, all right, in October 2022, you're going to write your data model, making sure they cover all of those questions. It's nicely and elegantly designed, I'm sure. It sits on top of these data sources that you need in order to answer all of those business questions. But then 3 months later, you got a new CPO joining or a new member of the team, and all of a sudden they start to ask new questions that you haven't really built a data model for. And also, you now have access to the financial data from Xero or other accounting tools. So what happens? You need to extend the data model. And this happens kind of over and over and over and over and over and over and over again. And what you end up with is a very organically grown data model that covers most of the historical business questions and is almost grown inductively in that way, but doesn't have any overarching design considerations. If you've managed to build a super scalable data model from the start, from those first 3 business questions, then come talk to me. I'm ready to offer you a job right on the spot at that point. It's very, very, very hard to do that inductively, people. So what's the clue here? I mean, I'm hoping it all sounds rather trivial. That's my goal here. The clue is to realize that those business questions might be transient. What's not transient is the business that sits on top of everything. Your business, particularly in your sort of very successful, fast-growing startup that you all work for, your business is relatively static, or at least the business model is relatively static. This is, by the way, why we typically work with companies around the Series A stage. That's typically when they have found good product market fit, meaning that they will not, almost never change the business fundamentals quite significantly. And because the business is static, you can start to think about what different questions might be rational questions to ask about that business. And the framework that allows you to sort of design the foundationals of your data model around the foundational elements of your business model, that's what we call domain-aligned data modeling. And I'd love to tell you a bit more about that, because I think that generally has been the game changer for us over the last couple of years in building scalable data models from the start in any project, rather than having to build a sort of quick fix version and then having to rebuild it 6 months later when the requirements has changed. So we're going to talk a little bit about objects and entities. We call them entities. Essentially, the realization is that a business is a loose collection of entities. Right? We are all entities, so one way or the other, of course, but a business is a loose collection of entities. Example, a company is an entity. A company has employees. An employee is an entity as well, and there's a relationship between a company and the employee, namely a company can have one or many employees. So I'm using Kraus-Foot notation here. Don't worry, that's about as technical as the sort of logical diagrams are going to get. Well, it's not entirely true, actually. I'm going to show you what a sort of finished domain model looks like. But when you start to think of your business like this, the question, the goal becomes, can I build a map of the business, completely theoretical, completely on paper, that describes the entire business in this set of objects and entities and their relationships? And the answer is yes, of course you can, probably in a few days' time. So this is a very simple example. I mean, just as a much more complex example, which we won't go through. So let's just very quickly talk through this one here. This is a very simple toy model almost. This is not a functioning business. It doesn't make any money whatsoever. It's actually just a subset of a sort of actual real-life domain model. It's very straightforward, actually. You've got a user. Well, a user comes from somewhere. A user comes because they went into the website, and at that point of this particular travel company, they can be regarded as a user because we define a user as a unique individual that triggers events on the website. So a user needs to trigger engagement events, whether that's a page view, a form, a submission, a link, and so on and so on. We have acquired users because they don't come from anywhere, they come from somewhere. So there's marketing engagement events for that subset of users that came in from a marketing campaign. And then you can talk about what those marketing campaigns consist of, and this is actually quite a full description. Marketing campaign, you might have a marketing channel, whether that's Facebook or Snapchat or TikTok or whatever you use. You have ads and creatives running in there, and those ads and creatives have placements, and those ad placements, they generate engagement events that then kind of get you users in the website. So far, so good, right? Yeah, okay, great. So a user can register and get themselves an account. They can sign up, and now they're an account user. And this is where domain modeling becomes interesting, because all of a sudden, we've got a proper definition of the difference between a web user and an app user. And we haven't looked at any data for this. You might just not even have talked in detail to the stakeholders yet. This is important because the amount of times that we've had to manage stakeholder expectations where one person was talking about users as everybody on the website, and the other person was talking about users as only registered users, and the other person was talking about users as only converted users. You got to make sure that your definitions are tight, and this type of modeling really allows you to do that straight from the get-go. Day one of any engagement we run, hopefully very early in the sort of journey of anybody joining a new analytics team in the startup companies over the next couple of months. And then, of course, I just put this here for sort of extra enrichment. User accounts can, for example, file customer support tickets, and customer support tickets get queried by customer support agents. But is the point clear that by doing the effort, again, it's not that hard to do this upfront to make sure that you have an understanding of the business, even though this might be quite complex as a diagram. The point is that this diagram reflects the entire business, the entirety of the business. If you remove any object or entity from this diagram, there's no business anymore because it will break down somewhere. You also don't have to add any additional entities because you're covering any possible kind of interface or touch point. Otherwise, you will get stuck in the next stage. But essentially, this is what we end up with as a sort of domain model. This is a model, this is a diagram that answers any question you might ever have about the business, because this describes the entire business. And we've built this without looking at a single available data point. Any question about the business? Sure. Say, for example, you want to know how many customers from a particular Facebook campaign have filed customer support tickets. Well, now you know that you can literally join the line, the relationship lines from the marketing channel all the way through to the customer support tickets over here. And there's your answer. You know exactly what sort of tables to join with each other in the presentational model to get there. Do this up front. Even if it's just a theoretical exercise for yourself, do this up front, because from here, your data model can be built. So now you can build your logical data model that actually looks at the available data and builds the columns and kind of builds the descriptions of the columns, builds the documentation around it, and so on and so on. And then very quickly, you end up in your presentational layer where you then can link it to your Explore design and your self-service capabilities, of course, making sure that all of this is surfaced to the stakeholders. All right, that's domain modeling. Very important, very useful tool, probably the biggest pitfall that we fell into, not doing that and building organically grown data models. Where does this live? In the middle of the stack. We get all the raw data in, we have this abstract idea of what the domain model needs to look like, and then we start populating it with the available data. And that might mean that at first, the first time you do this, you might only be able to populate 60% of the objects that you have in your domain model, because you know that you don't have access to the finance data yet, for instance, so you can't build the transactional tables and so on and so on. But at least you know where they will be in the domain model, and you can build your presentational model on top of a static target that doesn't change as long as the business doesn't change. The goal here is that you build a data model that does not have to change as long as the foundationals of the business do not change. Means you're out of a job as an analytics engineer? No, it probably doesn't, but it does kind of really allow to build dashboards that do not have to change any time that you swap out the data source. It allows you to build reports and deep insight that do not have to be completely changed any time that you add a new country to the sort of global mixture of where your company is active, etc., etc., etc. Sad stakeholders, pitfall number 3. Particularly important for us because, of course, we work by the grace of our clients, of our client companies. We want to make sure that all the stakeholders, all the business users are happy. And I think that reflects itself in a few different ways, not just in the way that you answer their questions and ask them what they actually need, and then work together with them to understand what it is that you can do to help, but also in how you structure data teams to sort of incentivize that in a sort of data team governance structure. So the first question there is self-serve reporting. Does it actually even exist? Is it a thing for startups? Different considerations in bigger companies where you have a lot more governance and a lot more structure typically, hopefully. For small companies, this is about how do you make sure that the CEO can build their own dashboards, and do we actually even want the CEO to build their own dashboards? And again, the sort of pitfall here is what we've done ourselves in the past, I'm afraid, and now certainly don't do anymore. This is an example of Looker. Most of you, I assume, will have seen a Looker Explorer one way or the other. It's an easy way to set up an interface between business stakeholders and the data models, where they can drag and drop fields into a viewer and then get data. Now, this is a relatively typical example. Actually, I took this from the Looker demos from a couple of years ago. This here, 153 fields. That's a huge amount of fields that you expose to your business stakeholder. There's no way, in my experience, that a chief product officer or a head of marketing will be able to understand what all of those fields do, even if you document even if you document them to the moon and back. I think the realization here is that you've over-designed the Explore. And not just that, there's about, what is this, about 12, 13 different date fields in there. So how can you expect your business stakeholder to actually understand what date field they need to use for their particular use case? And then the sort of realization is that they try to do something and then Looker pops up with a big error saying, well, actually, yeah, this is not really a data cube and we've kind of messed up the query here in getting your results back. Don't get me wrong, Looker is a phenomenal tool. We use it for almost all of our clients, but it's very easy to get in this sort of situation if you're not careful about what sort of Explore structure you surface to your business stakeholders. And then the worst case effect is that the business stakeholder says, okay, well, can I just have an Excel file instead and do it that way because I don't really understand how all of this works. The other realization I think, and I'm going to skip over this a little bit, but is that on the other side of the spectrum, you also don't want to surface purely aggregate results to your business stakeholders either. I'm not just talking about charts and so on here. But this is the sort of famous example of 4 different distributions that all have the same summary statistics, yet tell very different stories. So it's important that you are very careful in how you design the experience for your business stakeholders. What we do is we tend to have explorers in Looker that are very tight, that on top of the presentational layer only cover a particular subset of business questions, and this is where we do make the decision to kind of project and focus on a particular set of business questions. And actually, we don't even serve as explorers to most business stakeholders. What we do is so explorers being the interactive drag and drop environment, we always start from dashboards and surface a few dashboards to our end users using tool like Metabase that then allows them to maybe change the country field on there or add a pivot dimension and so on and so on, but is very, very well kind of curated with guardrails around it so that you do not end up in a scenario where your non-technical business stakeholder can't figure out what the Explorer is, even if you spent a lot of time building it around the object model that you have. There's other ways of telling stories, of course. We're a big fan of cumulative distribution functions as well, but I don't think any of the sort of major BI tools cover that at this point. So let's just skip over that right now. Second question in this part, what is the sort of efficient data team and what do communications and efficient data team look like? So we have got quite a well-established way of running our projects and running our delivery. We have to because, again, we're operate by the grace in favor of our clients. We have a very strong business value prioritization method. And that means that at any point in time, a client can always look at what we call a master plan for various reasons that has business value and time criticality as dimensions. So it's very easy to prioritize your sort of epics and the sort of bigger storylines that you're working on in the data team on top of that. And again, because we run as an interim data team, we typically transfer all of this process to the internal teams that we help build. And here in this case, build the emissions funnel. Very clearly, highest value, highest time criticality, priority order number 1 because of all of that. Just a simple sort of living document like this really helps. Then, on top of that, having very clear project management takes a bit of time. We use a tool called Monday for various reasons, but you can do it in Jira, you can do it in Asana, you can do it everywhere you want. But having very clear stories, that's the top here, that is almost on a sort of, that is actually on a stakeholder level. This in particular for the technical stakeholders of the client we're working with, but that then sort of split out into the detailed tasks and having an extremely clear business value, what actually are you informing in the business at this point, what decision are you going to make easier is always attached to any of these stories that we have. We then also go through heavy technical and business analysis, but I'll skip over that here as well. How do you work together on the back of that when you start executing it? We're heavy users of continuous integration and GitHub actually for all of our clients. Because we operate with most of the data modeling and analytics engineering being done in dbt, so with code, we can run through proper peer review, software engineering style development cycles. This is key because it allows not just for great communication and documentation when you're building stuff because you're forced to in the structures we've set up. It also allows you to do archaeology of a particular project quite easily because you can see the history of the pull requests and so on and so on. again, for bigger companies, it's table stakes. Small startups do this quite early on in your process. It will really, really, really help, even if you're just one person doing the data and business intelligence for a startup company. I'm blowing through my time a little bit, so let me just also mention that this is also where we run tests. Every time that someone opens a peer, every time someone opens a pull request, we automatically run a whole batch of tests around this: integration tests, unit tests, regression tests, making sure that when we deploy new features, the old ones don't break. Prioritize work, we talked about that. Very important, back this up again, data only has value if it influences the business bottom line. So data leads to insights that need to be actionable to drive better decisions, right? That improve business outcomes. Every step in that sentence is important. You need to ask yourself at any point, or we recommend to ask yourself at any point in time, is what I'm doing fundamentally delivering something that my business users can't just make better decisions based off, but actually influence that growth strategy, influence the bottom line of the company. That also means that if you're focusing on something, particularly here, if you're an audience member here at Crunch, including myself, focus on developing your business skill set as well as focus on developing your technical skill set. That sounds a bit sort of trivial, but honestly, it's really important. When we recruit or when we talk to candidates, we typically find that you can have an insane amount of technical expertise. If you're not able to link it to why it's important to the business you want to work for, or in our case, for the business that engages in a project, that technical expertise is relatively worthless, I'm afraid. So, strong statement, but think about it. In conclusion, just kind of wrapping up here, the three sort of spoiled tips I would want to give. One is design data models that are based on a domain model of the business, making sure they are not ending in chaos. Second, self-service reporting. It's great, it's fantastic, it really builds data culture. If people in your business, even if it's only 5 or 6 people, can engage with it, and you need it because you really want to avoid your technical CEO from writing SQL code themselves. But it can only work if it's curated. Otherwise, you're going to create a lot more problems for yourself than you might be aware of. And then always prioritize insight that's both novel and actionable for the business, ending in recommendations, as Kathleen said. And with that, we're at the end of this, and I thank you for your attention, and I'm sure we'll have some lovely questions to answer right now. Thank you.
Thank you so much, Thomas. You know, Slido is buzzing with activity.
Excellent.
And there's so many questions that came in just in the last couple of minutes. And the top one, when you're working in startup, data volume is very low. Where is the line when there is time moving to paid solutions and start building infrastructure?
Yeah, so I assume it's a question about the balance between, do you choose something that's paid for, do you choose something open source? Very simple, as in you can calculate it. Typically, open source solutions that do not have a simple Dockerized kind of containerization setup are probably not worth your time, right? Go for the managed service instead. That's very concrete. I'm sure there's a lot of issues with that, which we can talk about later. But my experience is that if you're on the fence between should you pay for the managed service or do you run it yourself, pay for the managed service, please. In a startup, your biggest resource is your own attention and time that you spend on things. What I'm saying about open core and open source tools is that there's a lot of tools out there that are trivial to run yourself. But there, the question would not be asked. I think this is more about a tool like Snowplow, where there's an excellent open source community out there, but it takes a lot of effort to run. Go for the managed service instead. Awesome, great.
The next one, is that domain data model available publicly somewhere? Where can I read it in detail?
In the recording of the talk, if you pause the frame, we're working on a few blog posts around this. I think one of the things that we struggle with is find the time to write all of this down on blog posts, but we were quite proud of what we do. I think if you, with all of these things, don't reinvent the wheel. Domain-driven design is an engineering concept that's as old as Unix almost, right? You will find amazing object-oriented software engineering practices, and you can apply them almost kind of verbatim into a data design world.
How deeply is the business user involved in the creation of a domain-aligned model?
They have to show up for the interviews because we're going to ask them about everything and then build that understanding. So they're quite involved. We're pen-holding, as in we build it, we draw it and loose it and go from there. but we need to understand what the business is like. Sometimes it's easy. Mobile app, subscription business, not that hard. We've done a dozen of them at least. Sometimes it's a bit more complex when you have sort of, an example is one of our current clients that is a train seat bidding platform. That's a little bit more complex because there's various different kind of data sources and objects involved in that data model. So quite heavily if it's a complex use case, yeah.
Okay. Do you see a lot of domain-aligned models that are similar to previous models you have built, and can you copy-paste older models?
Every company is different, but yes, yeah. No, it's in particular. I mean, we find in startup companies. I mean, we've done work with about 40 companies for the last 5 years. Most of them based in the UK, the Nordics, and Germany. I would love to work for Hungarian companies as well. So if you need us, then please raise your hands and we'll come talk. But yeah, there are use cases that are very clearly mapping. Think of it as a sort of Lego box, right? With sort of the what I showed earlier about how you acquire new users, what the digital marketing sort of the main model piece looks like. That is copy-pastable to almost every company we work with, right? So think of it more as different modules you can tie together.
You're on fire with this Q&A here.
Fantastic. Let's go.
We have 1 minute, one more question. You pick the question. Which one are you going to choose?
Oof. Why DBT for transformations? I'll use that. And that's not just because we're sponsoring DBT Coalesce later this month. It's purely a technical reason. There's a few companies out there. DBT essentially came out of nowhere over the last 3 to 4 years. We know their founders quite well. They used to run a company like Tasman called Fishtown Analytics in Pennsylvania, USA. They are by far the most sophisticated of the data model orchestration tools out there. We also love Dataform. We worked with Dataform a couple of times in the past. They were acquired by Google a few years ago to be put into the BigQuery ecosystem. DBT is ubiquitous. It's very easy to find expertise in the marketplace about DBT. It's very easy to write documentation. Their integrations with not just sources of data like Fivetran, Stitch, Airbyte, and so on and so on, but also with consumers of data, whether that's Looker or Elementary for testing or any other platform, are unparalleled. And their philosophy of running orchestration with directed graphs, doing everything via, I'm afraid, YAML files, but structured YAML files in a GitHub repo where you can run a lot of CI/CD on, just works very, very well for us. And we're not the only ones. It's a company that raised a rather exciting amount of money over the last couple of years. So we're excited to see what the ecosystem does over the next couple of years. Great.
Thank you so much, Thomas. That's
You're
all we
welcome.
got time for. Big round of applause for Thomas.
Thank you.